Welcome everybody to today's lecture. Today's lecture is for Tuesday, and I believe we're into week 10 already. So this is the last week of November, of October, before we move into November. So I thought it was worth taking just a couple seconds here, a few seconds here, anyways, to take a look at the academic calendar, because there will be a couple of holidays here in the near future that we won't have class. And so for the most part, I am treating this more or less like a grad course that we'd meet on campus, and that for the most part, generating lectures and material on kind of that Tuesday, Thursday schedule. And so if we don't have class on a Tuesday or a Thursday, then you can anticipate that there won't be a lecture posted for that day. So if we look at some dates here, November 7th, that's the last day to withdraw from a full semester course and receive a W, and that means that you've withdrawn all of your classes, I think. I don't know, it's kind of weird. Nobody in this class needs to worry about that, at least not from this class. November 11th then, that'll be a Tuesday, and that's a Veterans Day, so no class, there'll be no lecture that day. Thanksgiving break, this year it's going to span Wednesday through Sunday, so that Thursday of class we won't have any classes. All right, December classes resume, and then let's see, we're into final examination period. And this semester we kind of have this weird final exam period that splits. So it starts on the 11th, which appears to be a Thursday, and then runs to the 17th. So it runs over a weekend. We won't have a final exam per se, but I'll probably come up with a final project or a lab or something for us to work on. So you can anticipate that as the final, something that'll be due over the finals period, but it won't be anything like a comprehensive exam or anything. So just something to look forward to as far as where the semester is going. As far as content then, okay, so as far as, I guess, Dropbox goes, we just have Lab 2 that's out, and then the first project. We talked about both of those in the last lecture, so if you have any questions on those or you're not sure, please refer to that. If I left anything ambiguous there, then please reach out to me, send me an email or something, and I will definitely help provide any clarity there. So that's all that we have for now. Moving into the new material. So this week we're going to embark on really looking at the content from the Clean Code book. So again, the one book that was required. You'll see here that a lot of the slides, that's going to be content, more or less out of the book. And so our next lab, we'll have another lab or two here over the course of the next couple weeks after this one's closed. So next week at the earliest, probably a week after. We'll be looking more at some clean code exercises. So I'm trying to create some labs that are going to be similar to the material, the concepts that we're covering in the book. But as with all other labs, I will create a Dropbox. We'll talk about them in the video, and so you'll know when those are going to be made available. Okay, so with that here, we'll go ahead and we'll move into the slides. I'll get these slides uploaded, so if you'd like a copy of them, they'll be in the D2L section. Hopefully, I'll get those, I won't forget, I'll get those uploaded here before you watch the video, before this video has been made available. So we'll move into Clean Code, and there's an entire book, our one required book is going to cover this concept. Clean Code, what we're going to focus on here is writing good code, writing clean code, writing code that's easy to read and easy to maintain. And the main idea behind that is that it makes us ultimately more efficient. Okay, we'll start. This is the exact same comic or cartoon out of the book, and I just thought it was kind of funny, so I figured I'd put it here and start the lecture just in case you haven't had a chance to look at the introductory chapter of the book. And simply, the measure of code quality is the absence of WTFs a minute, or the rate at which those are coming out of the code review. So anybody that's ever been through a code review or part of a code review, whether you're leading it or it's your code that's being reviewed, I'm not saying that the WTFs are coming out of it, but usually that sentiment is very similar. And the more of this you have going on, the more you're probably the worse your code review is actually going. So I just thought some appropriate humor. Before we get into the concept of clean code, there's just some big picture things that I'd like to talk about, and the book talks about them as well. And that is this idea of what makes a good developer, and it's this concept of craftsmanship. And craftsmanship then is really what will separate those that can write good code from those that write bad code. And what the author proposes, and I agree, is that as a craft, it's something that can be learned. I have run into people throughout my entire career that just seem to naturally be really good, really talented programmers. They just seem to get it. And I've always felt like me, on the other hand, while some concepts come, I think, easy, others I've struggled with, and it always depends on the material. But I always feel that with enough effort and enough hard work, someone can become a good programmer. But they have to be very deliberate. They have to see this as a profession. They see it as a craft, and they have to put that kind of effort into it. The authors break down the craftsmanship into two parts: knowledge and work. So knowledge is learning principles, patterns, practices, and heuristics, and then the work is practicing it, getting to know these things inside and out. And this, I think, is critical. And that just because someone learns how to code, they go through a 4-year program or a 2-year program, or they learn on their own, and they've written a few programs, that doesn't mean that their craft, that their efforts to learn how to code should stop. Just because they know how to write code for a particular system, that they should stop learning how to write better code. Professional development there's still a very critical part of becoming a good programmer, especially as you move into positions of leadership and being able to mentor and identify and see when bad coding practices are being applied, or you see them when your developers are using them in the way that they're writing their code. So it's even more critical, I think, from a leadership, management, mentorship point of view. What can we do to help continue our learning? Well, we can take courses like this. We can further our education, get more advanced degrees. We can pick up books like Clean Code. And if you open up the first couple chapters, or I think even the introduction, the author talks about several other books that have been written that talks about code craftsmanship. And so, seeking these things out, and not just sitting down and reading them, but also understanding and then working hard at practicing what they are trying to teach you, and ultimately then coming up with an approach to writing good quality code, architecting good quality code that works for you, for your team, and for the way that you lead. It's a deliberate process, and as I mentioned, it takes a lot of hard work and a lot of practice. You will have to spend, and should spend, a lot of time professional development, reading other code, looking at good quality code, looking at code that's been developed by people that are doing a good job, reading a lot of professional material, having subscriptions to things like MSDN, the Microsoft Developer Network, and books like some of them that we've used for class to help give you the insights, give you the principles, the patterns, and the practices that you can then take and apply to your own environment. And so then it becomes an integral part of your viewpoint and your philosophy, how you approach coding and code development in general. I also think that it's very critical that not only you, I think let's say that we look at this from the management perspective, that you're not only doing it for yourself, because as a manager, you'll be busy. And odds are you're not going to be the one that does all the code reviews on your team. You don't have that kind of time. You can't mentor everyone on the team. And so you have to make sure that those senior developers that you have working for you, that you're managing, are also strong. They're strong professional developers. And so identifying that if you have them, that you cultivate that. If you don't, then how do you grow that? And making sure that they're given the same opportunity, that if you want them to read Clean Code, let's say that you go through this book in the semester and you just absolutely love it, and you want your developers to read it. Well, I don't know, what are the chances that if you give them a book and say, okay, now read this on your own time, that they're actually going to sit down and read it? It might not be that good. Odds are you'll have more success if you say, okay, as part of our Friday afternoon, the last hour of the day, or maybe Friday afternoon's a bad time to do it, but pick a part of time and make it so that it's professional development is a deliberate part of their daily process, their daily workflow, and you maybe have more success with it. So we don't want to just limit this development to ourselves and our ability to mentorship, but also cultivate it in others. Okay, so we move into this idea of clean code, and the whole purpose of clean code. How do we write it? How do we recognize it? How do we recognize the opposite of it, which is bad code or ugly code or dirty code, whatever you want to look at it, the opposite of clean code. And the whole purpose is to become a better programmer so that we can write better programs. Because time and time again, and I have worked on not countless, but a lot of projects, a significant number of projects compared to the number that I've touched over the years, that there has been a very large amount of work, very large amount of time and effort that had to be expended on, cleaning up, refactoring, rewriting code that just was really bad. And so our purpose here is that if we can approach or adopt philosophies, viewpoints, and techniques and everything to write clean code from the get-go, then it ultimately makes our ability to write code that much quicker. So that when we launch a program and we did it in a hurry and it really is ugly, and it's taken off, and 12 months later we're just finding that we can't add enhancements or features because it takes so much time, because there's just so much that has to go into adding these things and changing the code base. Had we started off with a clean code base, right now we wouldn't have that problem. Feature releases and those agile, the Git flow, some of those quick release, rapid release, continuous development life cycles that we've talked about, those will flow well. If you want to adopt that strategy and you don't have good code, you're going to probably run into a lot of problems. All right, so what does code represent, and why do we even care about clean code? You hear it talked about every once in a while that we'll get to a point where machines will write code for us, and that the role of the developer may at some point in time go away. I don't know how prevalent that thought is. I don't really think about it because I'm assuming that we're going to need programmers for quite a long time, and I think it's going to be quite a while before we see machines being able to write programs to the level that we need them written. Ultimately, code represents details of the requirements, and anybody that's worked on a project knows that the requirements can be some of the hardest things to nail down. We talked about that a few weeks ago, how critical the requirements are in the software development lifecycle. And they really are, but they're really hard to do, and they're really hard to nail down requirements that you can hand off to a developer, that they can interpret and write a program that captures 100% what that client was thinking. And what that programmer does is it takes those requirements and it has to turn those into instructions, precise instructions that the machine can understand. And so we've got this barrier here where the developer is the one translating these requirements. Sometimes vague, sometimes there's a lot of nuance, sometimes it's just ill communicated, and then making it so that the machine can understand them. So in that regard, even if at some point in time the number of developers does dwindle, and it's definitely not the career pattern that we're seeing right now in the industry, but at some point in time, if it does dwindle, there's still going to be a large demand for the good programmers, people that really understand how to write good clean code. Why does it matter? Why do we even care? Why do we even talk about clean code? Because if the code does the job, then it does the job, and that's all that matters. And that's not true, because when we look at a software project, we have to look at two things. What is the amount of effort that we have to put into developing it, and then what kind of effort are we going to have to put into it to maintain it? The maintenance phase, and you hope with any project that you endeavor on when it comes to software development, you hope that the maintenance phase is going to be the longest phase, because then you've delivered a product to a customer and it's a successful product, and now you're in that maintenance phase where you're continuously enhancing, improving, and fixing bugs and improving security. And so the maintenance phase can be a significant part of it. Good code matters, because if the maintenance phase, if you're getting into, and I just talked about this, if you're getting into a rhythm where it takes so much work, minor changes require so much reworking of the code base, then maintenance becomes very hard. Little changes become very difficult to do because they impact so many different places in the code. The authors talk about modules, and the modules can be functions. Okay, it's just we can look at code in a very modular way. A function is very modular. A function handles a certain piece of functionality or logic for the application. And so oftentimes that's what we're referring to. Different libraries, different classes, different functions, just modules within the code. And code will have a lot of different modules. Look at the examples in the book. Okay, so if you look at the book, and I think I just got my book here, so let me just double check that. I put page 3, but now for some reason that doesn't seem like. Yeah, okay, so it is on page 3. So with that example, what the author is talking about is there was a project, came to the market, it dominated. It was a successful project. But then as the project evolved, then there were just issues that kept lingering, that weren't getting fixed. Upgrades were being stretched out over months, and it got to the point where the consumers, the users of the product, just said, "To heck with it! I'm not going to use it. This isn't worth it." And now they're probably at the time, because I'm not sure what product they were talking about, but there were probably alternatives in the marketplace as well. So it's much easier to say, well, this product is no good. So and so does it better, so I'm going to use their product. When the authors interviewed one of the developers, that was the problem. The code base was just awful. It was hard to maintain, and they got to a point where they rushed the product. And this is going to be a common theme that I think when we deal with, project management, features, release dates, maintenance, and especially the quality of the code that we write, because that is like the number one thing that I run across personally as a consultant, as a freelance developer, and as someone that's worked for companies and startups. That has always been a big issue, is I'm trying to balance the time pressures, the deadlines that the people above me are putting down on me. And so how do we balance that with the ability to take time and write good clean code? The people then that authored that software, they said they didn't have time. They rushed it to the market, they got it going, it became successful, and now they were dealing with a big ball of mud. And that's spaghetti code or a ball of mud. It was just the code was terrible, the code base was terrible, it was not maintainable. And ultimately, because of that company went bankrupt. They just weren't able to keep up. I have some friends that are working for a company, and that's one of the issues that they're going through right now, is that they had some products that were developed by a couple of developers that maybe weren't the best fit for the job, as well as some pretty high demanding deadlines and timelines, and the product eventually got released, and now they've entered into that maintenance phase. And they're finding that in that maintenance phase, because some of those original developers are no longer there, that it's taking a lot of effort in order to add enhancements or functionality changes to that code base, because it's just so unwieldy, and it's just taking so much time. Their initial reaction was to add more developers. Well, if it takes this much time, then why can't we just add more developers to increase the amount of manpower that we're throwing at this problem? And of course, that isn't always the solution. And so the decision was ultimately made to essentially refactor the code, to just rewrite it all from more or less from scratch. It's not completely from scratch because the functionality is there. It's just the code has to be rewritten and architected in a way that made it more maintainable. And so, do you know what good code is? Do you know what bad code is? That's the purpose of this chapter, these first couple chapters, is start to develop your sense to be able to detect that. And a lot of times it's going to come with working on projects and just kind of learning, I guess, in a lot of ways, in the hard way, on what works and what doesn't. But there's some things we can do. There's some techniques we can adopt, and we'll see that with the next few slides here with naming. Naming can simply add a lot of clarity to our code and help eliminate ambiguity to make the code hopefully easier to read and easier to maintain. Okay, so kind of talked about why do we write bad code. I would say my number one excuse, and let's call it an excuse, is that I'm usually in a time crunch and the pressure's on, and I just need to get this working. I've reached a point with something that I'm working on that there's honestly times I just get to a point I no longer care. I just want it working because I need to move on to something else. And that's a bad excuse. That's me not acting professionally. That all the code that I write, I need to put the same amount of effort into making sure that it's clean, that it's well structured, that it meets corporate industry standards, policies and procedures, or best practices. That's what I'm looking for. Because oftentimes when I rush, and again this happens to me all the time, if I rush through and try to deliver on some code, maybe some functionality, and I write some bad code, it never fails. When I have to go back to enhance that or change that or do some sort of maintenance on it, it takes me a long time to go through the code and figure out what the heck I was doing. And so oftentimes when I do that, then I may have a little more time, and then I rewrite it. And so, there are times when something is so critical that just getting it up and getting it working, I have found it to be an okay band-aid, because then I have the time to come back and fix it. But I think the safer assumption is that I will not come back and fix it. So if I don't fix it now, if I don't make sure it's clean now, it's probably not ever going to get changed. Yeah, and then you can see with that last bullet, so that fourth bullet down, later is equivalent of never. It's very rare that it actually happens, and very rarely do I ever have time to go back and clean it up. So how does leadership respond to a mess? Well, in my last example, we talked a little bit about that. The initial reaction was to hire more people. Okay, so productivity is starting to slow down because it's taking longer in between bug fixes, security fixes, between feature releases. So what do? Throw more people at it? I don't know. That's a situation or a call that you as the leader or as a senior developer have to be able to figure out. When you see, as one of those developers, you see that it's the code base is the problem, then you have to have that sort of educated conversation with people in charge to say, no, I don't think it's more people, it's the code base. We need to fix this code base, and we need to come up with a plan to get it resolved as soon as we can, because if we don't, then this issue is only going to be compounded. Bringing new people in. What happens when we bring new people in? Somebody has to train them. They have to be onboarded. They have to understand the system. You assume that maybe they're an experienced programmer, but what if they're new? What if they're right out of college or right off the street with someone that's been self-taught? Then it's really hard because someone has to help them get up to speed as well. And so now you're taking away from developers that are already pretty busy in order to train them as well. So we really need to look at this from the two different perspectives, as the manager and also as the developer. What do we do, and what is the long-term fix? Is it bringing in more people or not? Is it refactoring the code or not? What is the most effective use for the team? What is going to provide the best long-term results? And then as the developer, what are we looking at in order to make sure that we as the developers are producing good code? And so it just boils down to weighing the options and keeping in mind that the quick fix can oftentimes result in messy code, which then can ultimately become more work down the road. Keeping it clean. It's cost effective, and it is a matter of professional survival. Cost effective. Okay, so again, and I'm kind of beating the dead horse here, but we have to look at the big picture. Write it. We're dealing with oftentimes, we're writing code right now to respond to some demand put on us by an organization, and then we also know that that code is going to interact with other components in the system, as well as we're probably going to have to come in and maintain that code later on. Okay, so we can't be so short-sighted that we only look at the now and say, I'll deal with the other later. We need to take the totality of the situation. And what if writing good code is simply the difference between delivering functionality tonight or tomorrow morning? What if I take the rest of this evening to write it, and then tomorrow I deliver it, or in 2 days? Again, it all depends on what the functionality is. And I'm going to say I've been in situations where I've made the choice to write not as a clean code in order to get something shipped out the door and up and running. And I felt that it was the best decision for me to make in that situation. So it's a tough one. All right? It's easy to say you'll always write clean code no matter what. And then when you live in the situation, you obviously have to make that decision. It is a matter of professional survival. Okay, so I've worked with several developers. And maybe I don't know what people have perceived of my code, but I have worked with other developers that tend to write bad code. They didn't understand some of the basic principles and patterns that result in good, clean, well-architected code. And so maintaining their stuff was a challenge. Professionally, it doesn't take long for that type of a reputation to build. Whether it's amongst your peers and your team, it's with your manager. And if it's a small enough industry, or you work in a small enough area within the region, Sioux Falls, the small town here, people can get reputations relatively easily, depending on how active they are in the community, on being really outstanding programmers or being mediocre or not so well. So it really is a matter of professional survival. What do we do when we decide that the code is so messy that we have to do a rewrite? Okay, so at some point in time, you're having this conversation with your team as the leader, as the manager, and that is the decision. You say, okay, it's time. The time has come. We can no longer. This is just taking. This is a detriment to the team. So if that condition, if that situation arises, how do you handle it? Okay, do we now create a second team, and that team is the one that's doing the rewrite, while the existing team is actually the ones that are still maintaining what's now going to be considered the old system? I mean, oftentimes if you embark on a rewrite, it's very hard, it's very challenging to rewrite a system as you're using it. And so what you'll have to do is you'll have to throw off to the side, and you'll have to set up a separate version of it and say, okay, this is the rewrite version, and now we have to develop these two systems in parallel until the new version is capable of handling what the old version did, and we can transition off of it. And so now, again, you have two different code bases, one that's different, one that's being completely rewritten, one that's the old one that has to be continuously maintained until it can be switched over. You have different individuals, more than likely, working on these two systems. And so now you're diverting resources, and oftentimes some of your best resources for the rewrite team in order to develop this new version. Plus, they're trying to keep up. They have to keep up with the old system, okay? And it becomes a race, and it can really become a very bad situation, because it's very hard. If the old system is still such a critical system that it's constantly being worked on and maintained, then it can take a long time for the original base to be rewritten, and then rewritten in a way that it keeps up with the old system. Ultimately, who's responsible for bad code? Okay, so we've kind of identified that. I think the individual, right? The author argues anyway that we, the developers, are. That it's primarily our fault because we're the ones that write the code. And so I would open that up and say, what do you think? Whose fault is it? You are authoring the code. You are, put yourself in the place of the developer, and you have deadlines to meet. And it's hard to sometimes really hard to push back on those deadlines, because your ability to slow the process down, to make sure that you're doing everything 100% correct. Business leaders don't always understand that. Oftentimes, I've been in, to harken back to my startup scenario, it wasn't always understood, the overall maintenance, the amount of effort, amount of time that goes into writing and architecting good code. And so what can happen is that when you are perceived as slowing down, then you're not maybe perceived as being as productive. Well, and I should say that wasn't necessarily the case in my last job, but it is an experience that I've had, and that just because I was trying to take my time and do things right, sometimes it comes across as being slow or doing things that didn't matter. Well, especially when there was others on the team or on a team that are willing to kind of cut those corners to get their stuff out first. And so it takes a lot of effort in order to make sure that you are writing clean code and that everybody understands. That goes into some of those basic, I think, leadership things, principles that we talked about in communication. And making sure that those that are pushing down on the deadlines, if you don't have a say in it, that you are voicing your opinion and voicing on why these things need to happen, how critical they really are, and making sure that they get done. Okay, the authors offer a simple solution for this dilemma that we run into. Previous messes slow us down. Making a mess, we make a mess to meet a deadline. So what do? And the author's solution is to keep your code clean at all times. Again, it becomes a challenge, but the more tools, techniques that we have for writing good code, the easier it becomes. The better our overall system is architected, the easier it is to then come in a hurry and write clean code. So it's easy oftentimes to recognize this. It's easy to talk about tools and ideas, but it oftentimes is very hard to understand how to actually do it. And so this goes back to what we talked about at the beginning of the lecture, and that is that we have to acquire it. We have to acquire the skills, we have to work hard at it, we have to practice, we have to understand, we have to push ourselves to learn more about software development and leading software developers. And then make sure that we practice it and live it every day. Once we've acquired these skills, it's oftentimes we're capable of being able to go back then and make bad code clean. And so it really can have kind of I can't think of the word I want to say, but the effect can be large once we really start to master, this craft of writing code, good clean code. We're authors first and foremost, and this was actually a concept that I never really thought about until recently, and that is that the programs that we write, we really want to make them readable. There's some examples in the book, and they talk about making code read like prose, making it read like a good novel. Well, as the author says, code is never going to read like Lord of the Rings. It really isn't. But there is an art, there is a style of making it very readable. And I think if you think about it in that context, it can change the way you approach writing your code. If you open up a source code file, and as you're reading through the code, it should have a logical flow to it. Variable names, function names, where things are declared, how the overall classes are structured. It should have a flow that makes sense, so that as someone is reading through the code, it makes their job easier. It doesn't hinder them, it doesn't make it harder. We spend a large amount of our time reading code and not necessarily writing it. I spend a lot of my time reading through code that I've written or reading through other people's code as I'm working on projects. And so the easier it is to read it, the easier my job becomes. And so I try to take that same concept and know that the code that I write, odds are, somebody else is going to have to read it. And if 6 months from now I have to read it, it's as well as I've never read it before. And so I'm doing myself and I'm doing everybody else a favor when I write good code, and write it in a good, logical, clean manner. Leave the code better than when you found it. This can sound, again, kind of easy to do, but a little bit harder to apply. Is it really that easy? I don't know. Yes and no. I think there is always possibility to make things better. The authors offer up a simple, with every check-in, fix something minor to improve the code, because we really don't want our code to rot. We don't want it to get bad. We want it to maintain the good quality nature of it. Is it easy to fix something? Can we simply go to check in our code and find a variable and change it? I don't know. It's hard to say. I think there is a lot of room for it, especially depending on the condition of your current code base, and if you're changing drastically the philosophy. If you go through this chapters and you say, "Wow, I've never thought about how naming was so important," and you go and look at some of your code and you see that the naming is really bad, then it can be pretty easy. You can say, well, let's look at, on this commit, I want to fix some variable names, and just add to the clarity of the program by fixing some of these names. Then you can really do it. You also have to keep in mind the scope of your commits. Okay, so I'm going to still talk in Git terms, but do you want to change, do some of these code cleanup items under the scope of your commits? I don't know. Maybe you're on a branch and you want to do that. Maybe you don't. But there should be the ability to fix and clean things up every time you touch it, and keep an eye out for it. If anything else, maybe you don't have a particular strategy going into how to make your code clean, but if you're at least aware of it and you're thinking about it, get others to think about it as well, then you can start having, hopefully, a very profound impact on the quality of the code. This material obviously can't guarantee that we'll become good programmers. This isn't a magic bullet type book. I don't think any of them are. But what it's going to do, what it'll talk about, and what I'm hoping to kind of convey through that, is the tips, techniques, and tools to get there. And so, things to think about, things that we can practice to make us better developers, better software development leaders. We're going to look at code. We'll look at some code in the book. We'll look at some code, hopefully, that I can find that are going to be similar examples, but not directly out of the book, because the code that they talk about in the book, they also offer their own solutions or ideas for it. So I want to look at some stuff so that we can offer our own ideas on it. We'll probably write some code as well. And I'm not exactly sure where that's going to go yet, because I want to kind of see how the material flows into the actual classroom, or into the class here. So we'll look at some code, we'll probably write some code, or you'll look at code and comment on some code as well. So probably going to be the foundation for the last couple of labs for the class. Okay, so that kind of wraps up the concept of clean code and just what we're trying to get basically out of the next few weeks together, the next couple of weeks together. The whole premise of the entire clean code book is is to write clean code. With this content, then this moves us into more or less into chapter 2, in which this chapter we talk about meaningful names. This is a short chapter, but I think it's a very impactful chapter, and that it's odd because as reading through this chapter, I've never, in my undergraduate computer science experience, I never had this kind of conversation with any of the faculty or in any of my classes. I learned these things through on the job, working in different organizations, understanding organizational policies or procedures or standards, working and talking with other developers, and working on other projects. But I never had anybody sit down and just say, hey, you realize that naming is important. And it comes. Most people kind of figure it out, I think, that it does have a big impact. But it's worth taking the time to think about it very deliberately, especially if you're in an environment where maybe you have a lot of entry-level or junior developers, because we'll look at some code here in a little bit. Not everybody, a lot of the, early programming education is focused on just learning how to program and not learning about some of these bigger picture techniques in order to write good code. We start, we name everything. When we look at code, everything we do in code is going to be named, and pretty much everything we do is going to be named by us. Okay, we name variables, we name functions, the namespace and files, the programs that we compile, the directories that they live in, everything we have to come up with a name. And so because our naming has such a great impact on our code, then we need to be very deliberate, and we need to put a lot of thought into the names that we choose in our programs and in our techniques. So here we'll look at some techniques. Okay, again, just like we rounded off the last slide there, we're just looking at techniques. Okay, so we can look at intentionally revealing names, avoiding disinformation, making meaningful distinctions, using pronounceable names, using searchable names, and then there's a couple other here that I didn't quite get on this list. Okay, so we want to talk about intention revealing names, and the name really should reveal the intent, and I think the book. Yes, okay. I think the book actually has a really good example. It takes time, and I don't know what it is about at least my mindset, but I have a hard time coming up with good names. I don't know why, but I really do. It takes me time. Sometimes I have to think for 2, 3, 4, 5 minutes to come up with good function names, good variable names, because it can be a challenge. I don't know why my mind maybe just doesn't work that way, but for whatever reason, sometimes I just hit a mental block. And so when I hit that block, sometimes I'm in a hurry, sometimes I'm anxious, and I say, okay, I'm just going to name it something dumb, and I'll come back later and change it when I come up with something that's more meaningful. And again, same problem. I'll come back later. Odds are I'm not going to come back later. And so once I type that variable name or I define that function, it's there to stay. So the purpose of this is to stop. Take the time right then and there to give it an intentional name. That name should reveal the intent. If anything requires a comment, if any variable name requires a comment, the author is going to say it's not a good name. I'll pretty much agree with that, but I will say maybe that it should require you to think about what you're naming it. Okay, so if you open up some code and you see in the source code int d, and then there's a comment behind it that says elapsed time of day. Okay, it's clutter. This comment is clutter. It's unnecessary because this is a bad variable name. Int d, it means absolutely nothing. Without the context of that application, this variable tells me nothing without this comment, and this comment should not be necessary. If this comment wasn't there and it's just int d, then I have to read the program. I have to figure out within the context, the scope of this variable, what is d doing? Okay, and now I'm wasting time. What if it was int elapsed time? Okay, elapsed time. Okay, well that's pretty good. I have a much better idea. Definitely eliminated the use of this comment, elapsed time of day, because the variable name itself tells me that. But it still can be ambiguous. Okay, it depends on what where this variable is declared and what it's doing. I might still have to try to read inside the context or the scope of that variable, inside that function, wherever it's been defined, what its actual purpose is. What if I said elapsed time in days, elapsed time in milliseconds, elapsed time in hours? That helps add a lot of intention behind this variable name. Okay, and this really gives me the best idea of what it's for, what it's going to be for. And so now I can read it, and I have to make one key assumption though, and that is that even though it was named something that is a good name, that it's used appropriately. Because sometimes you'll have names, variable names, or whatever, name something well, but then not used in the correct context. So, we assume here that we create a good name and that we use it appropriately. Let's see, I think I had another example I wanted to show. Yep, okay, I've got a couple. So we'll look at this one first. Go back to the slides here. Okay, so this is actually kind of a very similar example to one in the book. And that is that if we just are looking at this snippet, and I will never look at just a snippet. We're always going to look at the entire code file. So we'll have some context. But I can tell you, and we can look at the whole source code here in just a second, if we're just looking at the snippet, okay, what does x1 and what does x2 do? It's really hard to say. We know that it's being assigned a value from the roll of a dice, okay, or at least the return value from a function called to roll die. So we can assume that the values are being used for maybe a game or something, but it's really hard to tell for sure what is x1 and what is x2. Okay, so for the most part, pretty bad variable name, pretty bad name for an array because it does not reveal any intention. If we go to the actual code then, no, that's not the file I want. There it is. Okay, then we can start to read, and this is just a really simple program. We can start to read how many times would you like to roll the dice. Okay, so some printf output, we declare the variables, and here you can see again, one of those first rules that we just talked about was violated. If a comment is needed behind the variable declaration, then it's probably not a good variable name. And in this case, why not just change x1, x2 to dice1, dice2? Or the whole purpose of this very simple program is just to simulate the roll of dice. And so we could say that, dice1 rolls, dice1 roll results, whatever. The idea is we can add much more intention so that when we see that variable, in any context of the code, we understand what its purpose is. And we don't have to go back through and look for the declaration, look for additional comments, and try to build that context on our own. I had one more slide I wanted to look at here, some other code. Of course, I opened the wrong file again. Here it is. Okay, so we look at a class. We look at this file and this code. And this is a little more. There's a little more to this than the last one. This is some code that comes out of the Programming with C book. So it's some code that we use, or that I use, for my 250 computer science section. What this code is for a linked list. And so we have our main function. We have some insert, delete, print list. There's an instructions function. We have a structure. And a structure here is defining the node. And so with a linked list, I'll assume you're relatively familiar with that, or at least can vaguely recall what one is if you haven't used one in a while. It's just a way to take this structure and create a linear, it's almost like an array. You have this structure, it's going to have this data, and then it's going to link to the next node. And so then we can link these nodes together to form a linked list. Basically, it behaves a lot like an array. Now this code is just plagued with comments. And these are, I think, the worst kind of comments because they're block comments for a single line. So why the authors decided to do that just blows my mind. I don't know, but that's what they did. I can understand the comments because this is for a textbook. And so what they're assuming is that anybody reading this is learning it for the first time. And so the comments are going to help. Of course, if this was production code for for an organization or a business, you wouldn't want this amount of comments in here. At least I don't think you would. I think it's unnecessary. If we look at the structure though, okay, struct list node, we're dealing with a linked list. We oftentimes think of the items of the individual items of a linked list as a node, and that's fine. But let's look at, let's say we go down to this insert function. Okay, so this is the code that handles adding an item to the linked list. Right away, we declare 3 variables: list node pointer, list node pointer, list node pointer. So new pointer, previous pointer, and current pointer. And then we have a comment that says pointer to new node. Now, one thing that is recommended in the book, okay, so again, I can give some lenience here or some leeway here because the style might simply have been adopted in order to facilitate the learning. Okay, so whenever we're dealing with a pointer, the authors recommended early in the chapters on pointer is to suffix the variable with PTR or with pointer so that it's clear that what you're using is a pointer. That's fine, I suppose. But then this comment behind here is pointer to new node. Okay, so let's just pretend for a second then that this wasn't code written for learning, for educational. You know, let's say this is production code. What could we do to make it better? Well, we could get rid of pointer. We probably don't need that. We could keep it too. I guess it doesn't really matter. We could probably add new node. Okay, we could say new node or new node pointer. I would say that suffix is probably arguable whether you need it. But I think it's clear though that we know, the type here defines it as a pointer. And I think it makes this a little bit clearer if we say it's a new node. Same with this. Previous pointer. How about previous node? And current pointer. Current node. Okay. Some of this becomes very subjective because does this add more clarity to me? It does, because I know these are all pointers. And so current node, previous node, and new node, I think that it makes it clear what these are doing. Maybe I add the suffix pointer to it, in which case then we have new node pointer, previous node pointer, and current node pointer. Defining, we'll talk about a little bit here in just a little bit, defining the type in the naming typically can be avoided. However, if I'm doing a lot of development inside of a text, just a basic text editor, which is all this is, Sublime Text is just a basic text editor, I don't get a lot of the features that something like Eclipse and Visual Studio has. And so, it's harder for me to see these types without knowing that in the name. So, I can see going a little bit back and forth on those, kind of suffixing those things. Okay. But definitely changing the names, get rid of the comments, and adding some clarity. But now we change the name, and what do we have to do? We have to refactor. We have to go in here, wherever that said, new pointer, we have to find, let's see, new pointer, and we have to change it. Okay, so that could be a simple find replace, but find replace, we want to probably test the code to make sure everything worked. So it adds time. So when you look at, well, every time you commit, you just make a small change, a small improvement. How small is it? Do you have time? Do you have time to change this name, test this code out, make sure it didn't break anything, find all the occurrences? If it's a small function, usually it's not too bad. Changing this name from new pointer to new node really probably isn't that bad. I'd probably be pretty confident I didn't break anything, but it still takes time. Okay, so all right, so that was some code. Let's go back here. All right, avoid disinformation. Okay, so certain words will have meaning. Definitely in the context of programming, and so we want to be aware of what kind of names we're using, so that we don't convey the wrong idea to somebody. A list is a type. You can have lists in Java, and so if I create an object and I say account list, for a Java developer, they're probably going to look at that and say, oh, that's a list using the list object of accounts. Well, is it really? Is it really a list? And so does adding that on there, that little suffix there, that list part of the name, does that help further describe what that object is, providing that intentionality behind the naming, or does it add to the confusion because even though you're calling it a list, it's not actually using a list object. So you have to be very careful in the names that you're using when you're naming things. Be consistent in conventions, be consistent in capitalization. If you have an add function, make sure that it adds in the same way, across your code. If you have if you use a certain form of capitalization, try to use that same method of capitalization, camel casing, or however you decide to do it. Typically avoid, especially I, L, O, and O, and 0, so upper and lowercase upper and lowercase L, upper and lowercase I's can cause issues. Upper and lowercase O's and zeros, they can create a lot of ambiguity, and depending on the font style and everything, it can be hard to determine which is which. And so you just typically want to avoid those, especially as individual variable names. We don't typically want to use a capital O for a counter variable. It just is hard to know for sure if that's an O or a 0, although you can oftentimes tell, the zeros are going to be a little more elongated, the O is going to be a little bit more round. But it can be hard to tell, depending on the font styles being used by the system. Use pronounceable, searchable names. We're good at words. As human beings, we're good at words, and words are typically pronounceable. And so, for the most part, words are pronounceable. The words I use, my everyday vocabulary, are usually pronounceable. So we want to use pronounceable names for our variable names as well. We want to make them easy to pronounce because it just makes them easier to use in the system. We want to be careful. Again, let's say that we have a variable and we call E. E is a bad variable name. When we look at something that's searchable, okay, that's a part of making a word pronounceable, is it's easier for us to search, because oftentimes when we open up code, let's say it's a 5,000 line class, we're going to have to search through that to find the part of the code that we're looking for. And so if we start searching for words that aren't pronounceable, it can oftentimes make it simply harder to search for them. If we start searching for E, okay, E is a variable name. E is oftentimes, if you look at a try-catch block, try some code, catch exception E. We're catching that exception E. E is the variable name. And then we deal with that exception E as a variable in the catch block. If it's a lot of code and there's a lot of try-catches, there's going to be a lot of E variables. E is the most common letter in the English language as far as its use. And so a lot of variables and other functions are going to have the value E in it. And so if you're just simply searching through a file, it can take a while to find these things because of the names that were chosen. In general, the length of the name should correspond to the size of its scope. Okay, so we can get away with single letters if they're using a small function. We can get away with single letters when we use them with for loops, because those just are, that is a very standard practice. For I equals 0, for j equals 0, for k equals 0. But as the function gets larger, it takes more time to understand what that function is doing. And so if the variables aren't being descriptive, if they don't show us the intention behind their use, then it's harder to understand. It takes more time. It's not harder. It takes more time to understand what their purpose is in the scope of that function. Avoid encodings. And we're not talking about character encodings here. We're talking about encoding information into names. So type or scope information into names. Okay, so in general, we want to avoid it because we don't want to have to read a variable, we don't have to read a function and then try to understand that function or some information that's hidden inside of it. So we want to try to stick with the practices, the techniques we've talked about, and avoid encoding additional information into our names. A function will do something, a class is something, a variable is something. Look at this example. Okay, phone number. Okay, so we've got a type of phone number and a variable of phone string. Okay, what happened here? Well, at some point in time, we'll have to assume that maybe this was a string. This was a string, and now it's a phone number. Different object, different type. Did the variable get changed? No. And so now it is, it's misinformation. And that whenever this variable is used, if you're not looking at the declaration or you don't have an IDE that can give you information by interacting with the variable, you might not understand exactly what it is. It's not a string. It's a phone number. It's a different type of object. So we want to try to avoid situations when we change, the names and the types. If we change the type, we want to change the name. I apologize. I don't know where that bullet came from. That seems kind of out of place. I must have been thinking something else as I was typing these. Okay, and along the lines Okay, so this is disinformation or misinformation. If we look at a variable name like this, let's say we prefix this variable name with str first name, and then camel case it from there. Is the str prefix really necessary? Okay, if I'm a .NET developer and I spent a lot of years in .NET and I'm going to write .NET pretty much exclusively in Visual Studio, Visual Studio catches everything for me. It tells me as I'm typing things when I make errors, when the program won't compile, when let's say I have a string or a variable and I'm just not sure, I can hover over it, I can right click with it, I can interact with it. The Visual Studio environment itself, and Eclipse is going to be very similar, it's going to tell me a lot of information, quicker than I would when I go to try to compile a program. And so oftentimes, prefixing variables like this is really unnecessary. I don't need to know this is a string within the name because the IDE can tell me that information. If I'm in a simple text editor though, then it becomes a little more challenging because a simple text editor, I can't interact with that variable. It's not probably going to compile in real time, and it's not giving me that immediate feedback to say, oh, this is a string and you're trying to assign it the value of an object or something that's incompatible. But so we're going to assume we're working with a modern IDE, and so adding these prefixes, I don't think necessarily add a whole lot to it. I've worked with guys, especially older programmers. I tend to see this more with older programmers who worked in those systems where they were basically writing with raw text editors, and they did this to help remind themselves or to always indicate what type of a variable was in the program. And I just don't find it, for the most part, as necessary anymore. So some small changes that you can make is to remove things like this because it really doesn't add the clarity in a modern development environment. Avoid mental mappings. And if you go back I'll just cruise back there quick. Okay, in this case, this to me isn't a good example of mental mappings. Whoever wrote this code, they knew what x1 and x2 meant. And so they made a mental map of that, and that's just it. x1, x2, I know what it is. I've got a mental map, I know how they're used. You and me, never looking at the code before, we don't know what it is, and so we have to figure it out. So with this, clarity is king. Yes, I can write a program, yes, I can mentally map all my variables and understand what they are. That _d is really the object that represents the current date time. But anybody else that comes along and reads that, they're not going to know that. They're going to have to read the code to figure it out, and we're trying to save on the maintenance and on people having to come and do that. And so we want our code to be clear. Clarity is king. I, J, or K is good for a limited scope. It's good for a loop, but it's typically not good for any other variables. Ask yourself, what does it stand for, and do I have to read the code to figure out what it means, what this variable's purpose is in life? Some naming techniques then, as we move into kind of some class and object names, just some general basic rules. Classes and objects, we use noun and noun phrases. So good ones would be something like customer, wiki page, account, address parser. A bad one, or not as desirable, would be manager, processor, data, info in the name. We want to generally avoid verbs and stick with just nouns. Classes and objects typically represent some theme. Methods then typically are an action, and so they should have a verb or a verb phrase. So post payment, delete page, save, or save an object, save a payment, save whatever it's acting upon. So those are just some general, right now, some of those big picture techniques that we're looking at as we're going to start looking into more detailed implementations. Don't be cute, don't pun. Pretty much goes without saying. If you're cute in your code, it may be funny. It's only going to be relevant probably to that team, and the joke can quickly kind of disappear as the team changes. The authors have a function, holy hand grenade, and what does holy hand grenade do, or why is it even funny? I don't know. I mean, it's kind of funny if it deletes everything in the entire system, but for the most part, we want to just stick to the techniques that make up a good name for a good function. Be consistent, one word per concept, have a consistent lexicon, and try to avoid, and having this one word per concept, try to avoid having the same word for two different purposes, because then it gets harder to determine what that function is going to do we have to understand everything about the system, and maybe we don't have time. Maybe that's not the purpose of what we're working on. Either way, it's going to add more time because we have to understand it. And so, if we have an add method, it's great that it always adds. But what if we have another method that adds two strings together? Do we call that add as well? We need to be consistent with how we're using those verb phrases, noun phrases as we're creating objects and methods within our code. Okay, I think we just got a couple more slides here. So use solution domain names first, and what these domains are just talking about. When you're looking at naming, you can use CS terms. You can assume that whoever is going to look at your code, if you're looking at your code, you can assume, I think, that you're going to understand it. If somebody else is going to look at it, you can assume then that they're a computer science person and that they'll understand the terms as well. So within that domain then, we can use those terms. We can use terms that we think other computer scientists should relate to. We don't want to pull from the problem domain if we don't have to, because the problem domain then, it may require us to ask the client in order to clarify what we're talking about in the code. We can use the problem domain though if the solution domain doesn't exist. So if we don't have a choice because there's really no terminology that we can pull from, a base terminology that we can pull from, then use the problem domain. And what that at least provides us is, if we encounter a naming style or convention or concept, we just don't understand it, we can at least go to that domain expert for clarification. We still have someone to fall back on to help us understand how it's being used in this system. We can add meaningful context. So let's say that we have a set of variables. Okay, again, I see this very commonly. I've worked on a lot of systems that deal with addresses. So we have first name, last name, street, house number, city, state, and zip code. And together, that's pretty clear. We're dealing with somebody's address. But what if we're just referring to a state? What if we have a function somewhere in our application or in all the code that we have that's managing this big complex system, and all it is working on is a state? Well, we have the context of the state can be different. It can be the context of an address. Within the address, it can be a shipping or billing address. It could be the address for something completely, it could be the state for something completely unrelated. And so we can add a little bit of clarity to some of the variable names if we prefix. We can use a prefix. So in this case, we can add a prefix, ADDR, address state, or maybe just spell out the whole word, address state. And that may be able to add context to how state is being used. Okay, so we looked at that at the beginning with int d, and then we changed it to, I think it was elapsed time, and then we changed that to elapsed time in seconds. So there we were working with suffixes, but the same idea. We were adding more context to that variable so that it was very clear what purpose it served. We don't want to add unnecessary context though, and I see a lot of this actually in a lot of code I've looked at over the years, and that is prefixing things with organization or business names. And so I saw that a ton with name spacing and with some stored procedures and just all sorts of weird stuff. I'd made up an example of DSU. I have some different organizations in mind though. But putting DSU in front of a lot of things, or the organizational name. And the idea was, well, I'm separating it from the base Microsoft libraries or the base classes or this third party. But we don't really need to do that. We don't need a prefix with it. If we're talking about name spacing, the root of our namespace can be DSU or the organizational name, and so oftentimes it doesn't add any clarity or context to add organizational level prefixes. I'm not going to say all the time, but I think oftentimes it doesn't. Okay, so again, just kind of to wrap up the material here, the introduction to the book, I do find this to be a rather difficult task. I have a hard time coming up with good names oftentimes, and it's easier to say, you know what, I'll come back and do it later, knowing full well that I'll never come back and do it later. And so the idea here is we need to be very intentional about it, and we need to stop and take the time. And as leaders, when we're helping to cultivate that from our developers, we need to enforce that with them. Take the time, slow down, don't move on until you have a good naming. And you could take it one step further, and you could help with that, and you can create documentation. and say, here are our best practices for naming. Use this in this organization. And that'll probably go a long way, because if I don't have to stop and think about it, I just have to stop and reference that internal document, then I'm probably going to be a lot more likely to come up with good names, because then I don't have to sit here and twiddle my thumbs for 3 minutes while I think of something. I can just quick reference that Word doc, go, oh, yep, here's a good example, or here is a good pattern. I can apply it to my situation here and move on. There is this weird fear of renaming due to objections from other developers. And this is one of those issues, and it doesn't seem to be just limited to my experience as a developer. It does seem to be something that we just kind of deal with in the industry. And that is, I'm always afraid to change something because I think somebody else is going to object. Because somebody else named something and they like the way it's named, even though I don't think it's a good name, but I don't change it because I just don't want to deal with having to argue about it. And so, the bottom line is, don't let it stop you, don't let it stop us, and don't let it stop your team. If they think they can come up with a better way to name something, then encourage them to do it, and then talk about it. Try to cultivate an environment where it's better to propose a change and discuss it than it is to propose a change and have the original author or some senior developer crack down on them and tell them that was a stupid idea, because you don't want that. That doesn't help. That doesn't help anything. It doesn't facilitate or cultivate a sort of team environment. I've worked on teams where there's been developers that have been like that. They just were absolutely went out of their way when some sort of a naming convention didn't fit with what their worldview was, and they were very, I wouldn't say rude about it, but they weren't easy to just have an open and intelligent discussion about it. So it's a weird issue, and so I think the best you can do is try to cultivate a good environment and encourage people to, if you see a way to make it better, if you see a way to add clarity, do it, and we can talk about it if it really isn't. So, all right, that wraps it up. So we'll start on Thursday then. We'll move into probably chapter 3 and 4-ish, and just continue to look at some code and go from there. So if you have any questions on anything, please let me know. Otherwise, have a good week and talk to you guys on Thursday.